Hello everyone. Today we will explain how to deal or how to calculate some measurements, okay, and how to deal with calculation with certain measurements. So we will start by the maximum error in the calculation. How to evaluate the maximum error in the calculation. So we will take some numerical example as the perimeter of a rectangle. So we know that a rectangle is so we have a graph of the rectangle with four sides as we see on the right, okay, with four 90-degree angles, okay, with the two opposites where the two opposite sides are parallel and equal at length. Okay, so this rectangle, for example, the length and breadth of this rectangle were measured to be 8 and 6 centimeters respectively. So the length is 8 and the breadth is 6 centimeters. Okay, we know that a perimeter is equal or is same to sum to the summation or to add all the sides, boundary sides. So length plus breadth plus length plus breadth. Okay, so normally we can memorize that the rectangle perimeter equal to length plus breadth plus length plus breadth. Okay, or equal to 2, the double of the sum of a length and a breadth. Okay, so what the main idea here? First, to calculate the maximum error in the calculation involving some measurements. So in this example, first we calculate the perimeter of rectangle. We calculate the original perimeter using these measurements. So how? We add 2 times the length and 2 times the breadth. We obtain 28 centimeters. And then we write down the greatest possible error in each measurement. So the second step is to find the greatest possible error in each measurement. Here this the calculation of the parameter involve using the length and the breadth. We have two measurements here, so we have two greatest possible error. Okay, the greatest possible error can be unique or can be different for each measurements, for both measurements. Okay, so the greatest possible error here is we have 8 centimeters, 6 centimeter. We evaluate the greatest possible error with respect to the least the last significant figure. Here we the last significant figure is in 8, so the unit as centimeter. So we calculate the error with respect to the unit of centimeter. So it is equal to the half of the unit of centimeter. Half by 1 centimeter equal to 0.5 centimeter. And same as for the breadth. So we have the last significant figure is here, located in the digit of 1 centimeter. So the half of 1 centimeter equal to 0.5 centimeter. So for both measurements here, the greatest possible error is equal to 0.5 centimeter. So next, we find the limits of accuracy. Limits of accuracy. Normally, limits of accuracy we have lower limits, upper limits. How to find lower limit? Lower limit, we subtract from the original measurement we subtract the greatest possible error. And to obtain the upper one, we add to the original measurement, we add the greatest possible error. So for the length, we have the original one is what 8. To obtain the lower, we subtract the error, which is equal to 0.5. So we obtain 7.5 as lower limit of accuracy. Upper limit of accuracy, we add 0.5 to the original, which is equal to 8. 8 plus 0.5 equal to 8.5 centimeter. In the same way, we evaluate the limits of accuracy of the breadth. Okay, we have 6. We subtract the possible error, the greatest one, which is equal to 0.5. 6 minus 0.5 equal to 5.5 as lower limit, and the upper limit equal to 6 plus 0.5, which is equal to 0.5, 6.5 centimeter. So normally, when we find the limits of accuracy of the length and breadth, in this case we can find the limits of accuracy, lower and upper limits of the true perimeter, which involve using these two measurements, length and breadth. Okay, so normally here to obtain the lower limits of perimeter, we use the lower limits of accuracy of length and breadth, and to obtain the upper limits of the true perimeter, we use the upper limits of accuracy of length and breadth. Okay, so we use it. We use upper to obtain the upper limits, and we use, sorry, lower, upper to obtain the upper limits. Okay, in this case, they ask us to find the maximum or error, okay, to calculate the parameter. So the maximum error, we can use it as the difference between the original and the upper limit, or the original and the lower limit. So the maximum error equal to the upper parameter, upper limit of the true parameter minus the true parameter, or it is equal to the true parameter minus the lowest equal to 26, as we see here. Okay, true parameter minus lowest, or upper minus true parameter equal to the maximum error. Okay, so very easy. Should adopt the same steps to find or to calculate the maximum error in the calculation of certain measurements. So we can take as homework the first exercise, because we can emit this. It's just an imitation of the example 1. In the example 2, we have the masses of 2 bags of sand were measured and found to be 40. We have 2 bags of sand, each one, or the first is found to be 47 kilogram, and the second 52 kilogram, to the nearest kilogram. Okay, nearest kilogram, normally we use the last significant figure for each one, or first the total mass, the total, so it is equal to the sum. We add the two measurements, the masses of 2 bags to obtain 99 kilogram as a true total mass of the 2 given bags. Okay, the greatest possible error of each measurement. So normally of each measurement we had for the first, the last significant figure is here, 7 for us as kilogram. So 1 kilogram, the half of the 1 kilogram is 0.5 kilogram. And for the second, similar to the first, we have also the greatest possible error of each measurement equal to 0.5 kilogram. Okay, the limits of accuracy, we have upper, lower limit of accuracy of each mass, normally 47. If we subtract the error 0.5, we obtain the lowest the lowest limit of accuracy. And if we add to 47, we add the error 0.5, we obtain 47.5 kilogram as the upper limit of accuracy. Lower, upper. Okay, as similar as to we can evaluate the limits of accuracy of the second mass to obtain 51.5 as lower mass and 52.5 as upper mass. So the lower limit of total mass, total mass, lower limit. So we have the lower limit of the first bag and the lower limit of the second bag, etc. So upper limit, we add the upper limit of the first bag to the upper limit of the second bag to obtain 100. How to obtain the maximum error in the calculation of total mass? So we use either we use one of the following expression: a true total mass minus the upper, okay, minus, sorry, upper limit of total mass minus the true, or the true which is equal to 99 minus the lower limit of total mass which is equal to 98 to obtain finally 1 kilogram also. Okay, you obtain in the two cases we obtain the same value. In the second example, we have another example how the calculation involves measurement and how to evaluate the maximum error in the calculation. For example, we move to have some idea about the area of a given rectangle. We have a rectangle on the right here, okay? So we have length equal to 8 and breadth equal to 6. So we know that the rectangle area equal to length by times breadth. So the maximum error in a certain measurement, we should know that the maximum error, as we say before, it is equal the upper limit of this measurement minus the original measurement, or the original measurement, true measurement, we mean by original true measurement minus the lower limit of this measurement. So here they ask us to find the true measurement of the rectangle 8 by 6. As we see here, we have 6 centimeters square. Why in the perimeter we have centimeter? Okay, as we see here, we have centimeter, but with the area we have centimeter square, and we can see the next classes that the volume involves using centimeter cube, for example. Okay, what is the difference between centimeter and centimeter square? First, in the perimeter, we add the length and the breadth. Okay, how we add L plus B plus L plus B. Okay, and each one of these sides is calculated using the centimeter, the same unit, centimeter, centimeter, centimeter. So normally when we add, we obtain a number value, numerical value with the same unit of length, centimeter. For example, the measurement here is the unit of measurement is centimeter. Measurement unit is centimeter. But the area involves the multiplication of two values, and each one is given by the same measurement unit. So, for example, we have 8 centimeter by 6 centimeter. So normally when we multiply, okay, we multiply the values, and the same time we multiply the measurement unit, centimeter by centimeter equal x by x, a by a equal to a square, so centimeter square. So when we calculate any area of any graph, okay, So if any solid, so it is equal to the unit length or the measurement unit square. Okay, so in the same we use the same idea to calculate finally the maximum in the area, but in centimeter square. Okay, so we can move to, for example, like here, we have length and breadth of a rectangular room were measured to be 5 meter and 3 meter. So 5 meter, 3 meter, but the area is given by meter square. The true area of this rectangular room it is equal to length by breadth equal to 5 by 3 equal to 15 meter square. The greatest possible error is when the half of the 1 meter equal to 0.5 meter. The limits accuracy of length 5 minus 0.5, 5 plus 0.5 will obtain 4.5 and 5.5 meter. The limits of accuracy of breadth equal to like 3 minus 0.5, 3 plus 0.5, 2.5 and 3.5 meter. When we want to calculate the lower limit of the true area, lower limit of the area, okay, we use the lower limits of length and the lower limits of the breadth. Okay, so 4.5 by 2.5. Okay, we multiply the lower limits, and to obtain the upper limit, we multiply the upper limits of each measurement. We obtain the value of area of the lower and upper limits of area by meter square. Okay, and finally we calculate the maximum error to obtain the maximum error in the calculation is the maximum between the error, okay, that we obtained by subtracting the true from the true measurement true area from the upper limit of area, and by subtracting the lower the lower limit of area from the true one. Okay, and we should know in the remaining examples, we should know that to perform the numerical calculation and we should round the answer to the least number of significant figures in the given measurements. How? For example, we have the area, okay? We first perform the numerical calculation. We perform the numerical calculation 12.6 by 6.4, and we should know that 12.6 is contain three significant figures. Otherwise, the 6.4 contains two significant figures. So the minimum between 3 and 2 is 2. So we round the the calculation or the result, we round it to the least number of significant figure, which is here 2. So we round it to the second significant figure, which is 0. So we compare which is on the right. So 6 is bigger than 5, so we add 1 to 0, so we obtain 81, and we replace everything on the right by 0, so we obtain 81 centimeter square rounded to the two significant figure. And in the same way we found this paragraph, we can title it as rounding calculation to an appropriate level of accuracy. So we can set the level of accuracy first, and we calculate anything. For example, here we have 46 by 2158. We have, for example, here one decimal place, we have here a whole number, so with 0 decimal place, so we evaluate the result, we calculate our numerical results, okay, and we round it to the level of accuracy, which is equal here to the 1 decimal place, or 2, we have two significant figure here, we have here four significant figures. Okay, so to the significant figure, to the second significant figures, we have here, uh, for example, if we are based on the number of significant figure, we can round as we see here. So we have two significant figures, we have four significant figures, so we round the calculation to the second to the least number of significant figure, which is equal to two here in this example, two significant figure. Here, this example is we set the level of accuracy based on the number of significant figure. But if we base our idea on the degree of accuracy the on the number of decimal place, for example, here we have three decimal place. Okay, we have one decimal place, and here we have two decimal places. Okay, so normally we round here to the one decimal place, to the least decimal place accuracy in the given measurement. So we calculate the result 45.33. We take the first decimal place 3, and we compare the second one, we compare which is on the right 3 is smaller than 5, so we add nothing to the first decimal place, and we replace all the digits on the right by 0. We obtain 45.3 to rounded to one decimal place. So we have to set, as we said before, we have to set the level of accuracy, okay, based on the number of significant figure, okay, or based on the degree of accuracy, uh, in the core related to the decimal number of decimal places. Okay, and you see all the exercises, the solution of the exercises on the right, and you can take as a homework exercise 7. Thank you for listening. I'm waiting for any of your question, and bye bye.